SDC2021. I'm Richelle Ahlvers, Chair of the Scalable Storage Management Technical Work Group, as well as the Chair of the Storage Management Initiative. These two organizations work to develop, promote, and support the SNIA Swordfish specification. This presentation will talk about what's new with SNIA Swordfish. What have we been working on for the last year or two, and just provide an overview of some of the new functionality in the Swordfish ecosystem. First, we'll just start with a real quick level set. What is Swordfish? So to answer the question of what is Swordfish, we start with Redfish. The DMTF Redfish specification covers server, data center, and base fabric management. It's a RESTful API that uses JSON payloads, and then you have your choice of multiple types of schema that you can use to understand and develop in this ecosystem. Swordfish is built on top of the Redfish specification. We leverage the protocols, definitions, services, and all of the base capabilities within the Redfish ecosystem. Swordfish specifically focuses on adding these storage-specific extensions to Redfish. We cover a lot of use cases, everything from big iron, large external storage, down to NVMe configurations. We'll talk about that more in a little bit. We cover block, file, and object. We extend the traditional storage domain. Due to our tight coupling with Redfish, we can expand to include converged environments and converged management, so providing server storage and fabric management in a single seamless ecosystem. Swordfish also provides the option for implementation of a class of service-based interface for those implementations that are looking for that additional value add in their management stacks. We provide a standardized way to reflect that. So what's new? In the last year or two, we've been working on a couple major new pieces of functionality. First is adding support for NVMe and NVMe-oF devices. So we have not been doing this on our own. We've been working an alliance partnership that includes the DMTF Redfish group, as well as the NVM Express, NVMe, and NVMe-oF experts to marry our ecosystems together. We've also been working on managing storage fabrics through yet another alliance partnership. So DMTF and SNIA are again working with OFA to work on expanding and completing the definitions of fabrics in Redfish, and then adding the storage fabric management and expanded use case support. In addition to that, we're working on a lot and have delivered a lot of enhanced documentation with more to come. We've added new functionality in the user's guide, mapping guide, the error handling guide. We have new capabilities coming out around capacity and metrics management, which I'll talk about in a little bit. And we've also added some new documentation. So let's talk a little bit about what expanding support for NVMe and NVMe-oF looks like. We started in 2020 adding support for NVMe modeling and basic device support. The 1.2.x releases of Swordfish all include incremental capabilities in the NVMe space. We've just released version 1.2.3, and we will have 1.2.4 coming out later this year. There's a lot of NVMe specific content in there. We've added spec and schema updates for new NVMe specific properties. We've added use cases that are NVMe specific into the user's guide. And we created specifically for the NVMe portion of the ecosystem, the NVMe model overview and mapping guide. So this has detailed descriptions for developers to implement the NVMe management interfaces. If you are an NVMe person learning Redfish, it includes the mapping there. It's written from a Redfish Swordfish perspective, and organized from that perspective, and provides a mapping from all of the objects and properties that we're asking folks to instrument for different device types to where to find that functionality in the NVM Express specifications. We also have a bunch of functionality available at swordfishmockups.com and a whole set of NVMe specific mockups. We've also been developing a lot of profiles. This has been a focus this year, is going back, and once we've had those models in place and a lot of the base capability and mapping done, going back and developing specific profiles to provide implementation guidance and requirements for different configurations. We've supported NVMe drives, Ethernet drives, and advanced NVMe drive features earlier this year. And then in the 1.2.3 release, we just came out with a profile for the NVMe front end specification. So we use those for complex devices such as arrays. So where a disk array may have a completely opaque back end, we can model this NVMe front end. So it could actually be using a traditional Swordfish representation for a portion of the device, and then including this new NVMe front end representation to show the NVMe-ness of the system. So another thing about all these profiles is we use the profiles as one of the key components to feed the Swordfish Conformance Test Program. We now have CTP testing available for these first three that I just highlighted for NVMe drives. Some of the work we had, some of the other items we have coming soon are additional, spec, profile, mockups, use cases, enhancements to the mapping guide for a few more configurations. Those include the NVMe JBoF, and NVMe e-BoF, and then we'll be moving on to what we call the NVMe-oF exported logical subsystem capability. Moving forward, we'll also be, just working to track new NVMe Express features with additional Redfish and Swordfish releases. So for a deeper dive in this area, check out Curtis Ballard's presentation, Completing the Picture for NVMe and NVMe-oF Management, Guidelines for Implementations. This really takes you through what all of these different pieces are, how they relate to each other, and how to use them. When we're talking about doing NVMe functionality, what does that mean? What are we doing? What have we done? We basically took all of the NVMe objects and said, how do they map to Redfish and Swordfish models? And for the most part, we have a fairly straightforward, one-to-one mapping. And we have a couple of places like NVMe domains where we've just needed to create an absolutely new construct because it didn't exist in the NVMe space. We leverage a lot of the existing Redfish and Swordfish storage models, and we also will be leveraging things in the Redfish fabric model as well for the NVMe-oF capabilities. Let me walk through a little bit of what that looks like. On the left side of this, you see kind of a traditional Redfish Swordfish hierarchy. These purple model could be used for any type of storage device. This could be the same model for say a disk array today. What we've done with NVMe is basically also said, here's the hierarchy and the relationship of all of the NVMe specific objects on the right. And these then got mapped very nicely. For the most part, there are a few places where we had some slight inconsistencies in the model, but that largely comes in the space of the controllers, where traditionally the controllers on non-NVMe devices reflect the actual physical controller in the system, and the management controller, that kind of thing. In the NVMe space, a controller is more of a logical construct. Well, we've kept that mapping anyway for the consistency we're looking for here, and it honestly works pretty well. The other objects you can see we use are volumes, pools, and chassis representations for physicals. All of these map then to these objects in the NVMe space. If we want to look at a little bit of an application of that, here's a view of how we dropped in an NVMe drive into our standard Redfish Swordfish model. So we start at the service root and we go to a collection resource. This is basically a group of like objects. So in this case, it's the group of all of the subsystems. We're modeling a single drive here. So in the NVMe space, there's a single subsystem, which is instantiated here in this singleton resource. And then there are related to that NVMe controllers, which leverage our controller object and hierarchy. So you can have IO, discovery, and admin style controllers. And then namespaces are, of course, volumes. So inside these more comprehensive object models for advanced capabilities like endurance groups and sets, those are mapped as pools. And out of those, you can create namespaces. And then in the chassis space, of course, to represent all of the physical entity components, power, thermal, LED, all of that, a kind of information, we leverage the drive object. If we look at how we're applying the same thing to this new functionality that I mentioned was on our list, the NVMe-oF exported logical subsystem model, you can see a lot of similarities here. Once again, we wanted to keep consistency with the base, not only the base Redfish Swordfish model, but the base NVMe models. So these exported constructs over here map directly to these blue ones, where the blue ones are, these are the Redfish Swordfish models we've used for NVMe. And that takes care of a lot of the basic capabilities. When we want to talk about more advanced capabilities in the exported logical subsystem model, like allowed hosts, we bring in that Redfish fabric model that I mentioned earlier. For a deeper dive into all of this functionality, what specifically we're mapping and how this all works, check out Phil's presentation, Managing Exported NVMe-oF Resources and Fabrics in Swordfish and Redfish. Moving on to storage fabric management, we have been working again with DMTF and OFA to apply and extend the Redfish fabric model to multiple fabric types. So Redfish has a very solid model in place for fabrics, but what we're doing with OFA is looking across the fabric types to really flush out those models, make sure all properties are there and full instrumentation is in place in Redfish for those. Once we have that done, and those basics are in place, then we can work on making sure that the storage-specific use cases and capabilities are there. That includes not just the base configuration, which we're working to expand that Redfish fabric model to include, but storage-specific things like workload optimization and performance instrumentation. If you want to see a little bit deeper dive on where we are with this effort, check out Eric's presentation, Managing OpenFabrics with a standards-based interface, bringing Gen Z, Redfish, and Swordfish together. This is a little bit, talk a little bit about what we're doing in these areas and where we're touching the models from on the fabric side. There's really two different things you can represent in the Redfish fabric model. One is connectivity, the other is access rights. So taking a look at connectivity first, this is kind of where you think of classic fabric management, where you have, you're representing that connectivity of switches, and then you've got zones to help configure, inclusion and exclusion of the infrastructure. So in this model, we use switch, endpoint, and zone within fabrics to manage all of that connectivity modeling. When we want to look at access management, in particular at multi-system access management, we also use the fabrics model because a lot of these concepts are very similar. What we do instead is we use connections in addition to endpoints and zones. So a connection is really where you specify what the permissions are, access permissions are that you want to see applied to particular targets. We've been talking a lot about, fleshing out the model, expanding details. How are we doing that with working with the OpenFabrics framework? What we're really doing is the OpenFabrics management framework is an open source reference implementation that works across different fabric types to instrument what I highlighted a little bit ago, which is that connectivity model. So switches, endpoints, and zones. All of this work basically uses these objects and models directly. The OpenFabrics management framework will have a Redfish and Swordfish front end on it. So if you want to see more information, again, please check out Eric's presentation. In addition to that, we've been doing a lot of enhancements to the Swordfish documentation. So we have one brand new document, the Swordfish Property Guide. This is really just a quick reference for, for clients or developers to get information about what's a property, where is it used in the system, if they're for a specific property, and what's its definition. We've also done a lot with expanding the users guides, the mapping guides, and the error handling guides. There's new use cases for NVMe as well as other configurations. We've expanded the user's guide to cover more use cases for remote replication in general. And the mapping guide, as I've already covered in the NVMe section, lots and lots of new content there. The error handling guide also has some new guidance for error cases and error handling reporting. We have some new documentation coming as well in the area of standardized capacity and performance metrics management. We'll be releasing two components for these, one of which is a set of templates that implementations can use as the basis to provide standardized instrumentation and reporting in the telemetry service, which is where we instrument in metrics and metrics reporting in the Redfish model. There's also a white paper coming that documents what specifically to do and what are the expectations for this functionality and capability. Look for that hopefully coming in the next release, version 1.2.4 of Swordfish. We've also got a lot of work done in the tools ecosystem. Don will talk a lot more about what's there and what's going on in the expanding development of your Swordfish implementation using open source tools. But what I want to do is call out a couple areas where we've added a lot of, where we've had a lot of work happening in the last few months. In particular, we've had a huge focus on emulators, and emulators can serve a great tool, as a great tool to help in initial implementations and trying out concepts and seeing how they work. It's kind of an expanded version of a mock-up in a lot of respects. So we actually have 3 different emulators available now, and Don, again, will talk about these in a little bit more detail, but for the Swordfish API emulator, for example, that one's been around for a little while. What we've done this year is really extend that and to help use that as a basis for some of this joint work. In particular, the OpenFabrics Management Framework work group and the POC that is being developed for that OpenFabrics Management Framework is all being done on top of the Swordfish emulator. So what we've done there is we've gone back and fleshed out and ensured that the basic models are there for Swordfish, as well as adding a bunch of objects into the fabric model and other parts of the system to enable all this POC work. There's 2 other emulators, DEM, which Richelle and Gadi will be presenting on as well today, that is really just focused on NVMe and NVMe-oF capabilities. It's got the capability to be both a simulator and an emulator. So that's kind of a unique perspective as well. There's a third one that's been developed as well. It's called Fish'em. It is not available on github.com/SNIA. We can provide a link to that in Dawn's presentation as well. The difference with this one is really that it's a schema-aware emulator. So while it is not necessarily doing checking of behavior, it is working more to validate that anything you are working within the emulator conforms to Redfish and Swordfish specifications. The Swordfish API emulator does not have those restrictions, so it's actually a really good tool to use to try out things before you create the actual schema and make that part of Redfish and Swordfish officially. There's also a bunch of enhancements to the test tools I'll be talking about in my presentation about the Swordfish Conformance Test Program. And in addition, we have expanded capabilities to our PowerShell-based tools. These are all available on github.com/SNIA. The PowerShell tools has just added support for Redfish, and so that it kind of completes the model. The original Swordfish instrumentation focused on that logical representation. Adding the Redfish one in not only allows it to work against Redfish systems, but it also provides all that chassis representation as well, which is common and derived from Redfish. A lot of stuff going on here. I hope this was helpful in trying to provide a little overview of what's going on. Please check out the rest of the presentations today. And here's a bunch of references to us and our partners. There's pointers here to snia.org/swordfish. That's kind of the key place to go find any of that information about Swordfish. If you have questions, if you're a SNIA member, you can join the twig and work with us to enhance the spec or to get your questions answered. If you're not a SNIA member, you can always go to swordfishforum.com and ask questions about Redfish and Swordfish. To find information about Redfish, go to redfish.dmtf.org. And NVM Express, look at nvmexpress.org/developers for all the specifications. OpenFabrics Management Framework, check them out at openfabrics.org and look for the OFMF working group information. Thanks a lot for watching. Please enjoy the rest of the presentations today, and don't forget to take a minute to give us a 5-star rating. Thanks.